Hello! In this activity, we're going to learn about the magnetic flux. You can see a piece of mild steel bent into a U-shaped yoke onto which block magnets can be fixed. In the center is a transparent plastic former with a coil of wire wound on it. Let's drag the flux density slider to the far left to add magnets to the yoke and produce a magnetic field. The flux density B, measured in Tesla, which is symbolized by capital T, is a measure of the strength of the magnetic field. As the magnets increase in size and strength, the flux density increases. Let's select field lines to show the magnetic lines of force or lines of flux between the red north pole on the face of one magnet and the blue south pole on the face of the other. The lines flow from north to south and some pass through the coil. Let's drag the slider back towards the central zero position. What happens to the lines of force as you do this? Yes, they decrease in number and grow further apart. Now let's drag the slider to the far right. What happens? Yes, the magnetic poles are reversed and the lines of force become more densely packed. That's great. Good job.